Okay, Assalamu alaikum warahmatullahi wabarakatuh. Today, inshallah, we will be working on practical problems related to projectile motions, starting with a scenario of a projectile launched horizontally. Now, think of a cannonball. You have a cannonball fired horizontally. So we have here a cannonball fired horizontally. When we describe the launched as horizontal, this means that this angle here is 0 degrees. So horizontal, that means the angle should be 0. The angle with the horizontal is 0. Aligned with the horizontal line. In our calculation, we will assume there is no air resistance because air resistance will affect the trajectory of projectile. This will simplify the motion. Now, the initial velocity of the projectile okay, let's go here to initial velocity component, slow motion. As you notice, the horizontal velocity, the velocity in x direction, the length of the arrow is constant. The length of the arrow is constant. Okay. And the length of the arrow in the vertical direction keep increasing. So horizontal velocity is constant and vertical velocity in y direction start with 0 initial velocity and then increases till it reach maximum just before it lands. Now the equation for when we solve projectile motion, we have horizontal motion and vertical motion. For horizontal motion, we're going to use always the same kinematic equation we've used before. So the kinematic equation that you're familiar with, which is V final equals V initial plus acceleration times time. This is the first equation. Second equation, delta x equals V initial times time plus acceleration times plus half acceleration times delta t square, and the last one, V final square equals V initial square plus 2a times delta x. Now, when we're talking about when we talk about horizontal motion, V acceleration in x direction is 0. So all the second term here will be gone, is gone. So for the horizontal motion, we will have V final in x direction will equal V initial. This is the first equation. Second equation, delta x will equal V initial in x direction times time. And third equation, V final in x direction equal V initial. It's the same as the first one. So in horizontal direction, we will have only two equations. So the equation will be in horizontal direction, Vx equals V final x direction equals V initial, final in x direction, V final in x direction equals V initial x direction, and delta x equals Vx times time, total time. And I don't have acceleration in x direction. Delta x here is the range of the projectile. So if you have a projectile launched horizontally, because today we'll focus on projectile launched horizontally, this will be the height of the projectile. This is the initial speed or velocity in x direction, and it will land, it's parabolic, it will land, for example, here. The horizontal distance, delta x, always horizontal x direction, always. Vertical y direction. The height of the projectile, this one, is delta y. Okay, now V initial is always the same, V initial the same. Now V initial in y direction, I'm going to start with 0 because the projectile at the beginning wasn't moving in y direction, and then this velocity keep increasing till it become maximum v final here in y direction, maximum just before it hits the ground. In y direction, we'll have three equations. I don't have, as I said, I don't have v initial. In y direction is 0. So the first term in kinematic equation is gone. I will end up with the second term only, which is half ay delta t square. This is the first equation. And v final y direction ay times delta t. And the last one, v final square equals 2 acceleration times delta y. Now we start with the first question here. The first question we're going to solve, and I shared this document with you already on Tuddle. The question here, we have baseball. Let's see the question. Here we have a base. Let me take the question, screenshot, and paste it here. Okay. So we have a baseball rolls of 0.2 meter height. So this is the height of the baseball. Okay. The height is 0.7 height, always is delta y. And strike the floor 0.25 meter away from the base of the desk. So it will go with initial speed in x direction, and then it will hit the ground. When it lands here, the horizontal distance delta x is 0.25 meter. Okay, since it's moving down, delta y is negative. V initial, we said always in y direction, equals 0, and acceleration y direction equals negative 9.8 meter per second square. Now when we solve question that is related to projectile, we're going to make x and y horizontal motion and vertical motion. X for the horizontal motion, y for the vertical motion, and we have two equations, always start from the horizontal direction. So the first equation, v initial x direction equals v final in x direction. This is the first equation. Second equation, I have delta x equals v initial in x direction times delta t. Now delta x is given to me, which is 0.25. V initial in x direction, I don't have it, and I don't have delta t. So I'm going to keep this equation. We'll come back to it. Now let's go to y direction. Y direction, I have three equations. And since I have delta y is given to me already in the question, so I can use the second kinematic equation. Now remember, I don't have v initial y direction is 0. So the first term of the kinematic equation is 0. So the equation will be delta y to indicate the height equals half acceleration y direction times time squared. Remember, it's moving down. Y is negative. Everything is negative. Even acceleration is negative. So delta y will be negative 0.7 equals half times negative 9.8, half times negative 9.8 times delta t square. So this will be negative 0.7 equals negative 4.9 delta t square. I'm just going to erase, make some room for me. Okay, here. I'll erase here. Okay. So negative and negative, they cancel out. I'm going to divide both sides by 4.9. So delta t square will be 0.7 divided by 4.9. I just divide both sides by negative 4.9, negative 4.9. Now I need delta t, take square root for both sides to get the value of time, total time or time of flight, and this value will be 0.38 seconds. Okay, since I have the time, I can find how fast was the roll rolling, which is the initial speed, and the equation that I can calculate the initial speed in the horizontal direction is this one, the first equation. So what I'm going to do, I'm going to substitute the value of time in this equation. Okay, let's rewrite the equation again here and substitute here. We're going here in x direction now. So in x direction, I have delta x equals v initial x direction times time. Delta x is 0.25 equals v initial x direction and time here 0.38. I need v initial, divide both side by 0.38 by 0.38 and you will get v initial in x direction 0.66 meter per second.